Right now, 45 billion kilometers from where you're sitting, a machine older than most of your parents is quietly running out of power. And the people watching over it have finally admitted something they'd been avoiding saying out loud for years. Every single message Voyager 2 sends back to Earth could genuinely be its last one. Not someday, not eventually, right now, today. This exact message could be the final transmission we ever receive from the most distant human-made object in our species' entire history. That's not a scary headline dreamed up for clicks. That's an actual quote from a NASA, a scientist working directly on this mission. And once you understand why they're saying it, the whole story becomes far more emotional than any fictional doomsday scenario could ever be. Let's rewind for a second, because most people have completely forgotten just how old this spacecraft really is. Voyager 2 launched in 1977, before most people alive today were even born, riding a wave of ambition that NASA itself only expected to last 5 years. Its job was simple on paper: fly past Jupiter and Saturn, take some pictures, gather some data, then quietly fade into the background like every other mission before it. Nobody, not a single engineer on that original team, expected this tiny machine to still be talking to us nearly 50 years later. And yet here we are. Voyager 2 has become the only spacecraft in human history to fly past all 4 outer giant planets, Jupiter, Saturn, Uranus, and Neptune, giving humanity our first ever close-up look at 2 worlds we have never revisited since. Think specifically about Uranus and Neptune for a moment, because this detail tends to get lost in the excitement of the bigger story. Voyager 2 remains, to this very day, the only spacecraft in the entire history of space exploration to have flown close enough to either of those 2 ice giants to capture detailed images and readings. Every photograph most people have ever seen of Uranus's pale blue, green surface, every measurement of Neptune's wild storms and its strange, backward, orbiting moon Triton came from this single spacecraft during flybys that happened decades ago. No other mission from any country has gone back since. If you want to see either of those planets up close today, the only real option scientists have is pulling up the exact same dataset Voyager 2 gathered during those flybys in the 1980s, because nothing newer currently exists. That fact alone should put into perspective just how much irreplaceable value still rides on this one aging spacecraft. It isn't simply a nostalgic old machine drifting through space for sentimental reasons. It's currently the single source of certain kinds of information about our own solar system that no other instrument anywhere has ever managed to replace. After finishing that planetary tour, Voyager 2 kept going, pushing further and further from the Sun, past the orbit of Pluto, past the edge of where our solar system's magnetic bubble even ends. In December 2018, it officially crossed into interstellar space, becoming only the second human-made object ever to leave the protective bubble the Sun creates around our entire solar system, joining its twin, Voyager 1, in a region of the universe no other machine built by human hands has ever touched. Think about that phrase for a second: interstellar space. This tiny spacecraft, built with less computing power than the calculator sitting in your phone's calendar app, is currently drifting through the actual space between stars. But here's the part almost nobody talks about, and it's the real reason this story matters right now. Voyager 2 doesn't run on solar panels. Out where it's flying, sunlight is far too weak and far too distant to power anything useful. Instead, it runs on something called a radioisotope thermoelectric generator, a device that converts heat from slowly decaying plutonium into usable electricity. When Voyager 2 launched, that system produced around 470 watts of power, roughly enough to run a couple of household appliances. But radioactive decay doesn't care about our timelines or our hopes. Every single year, without exception, Voyager 2 loses about 4 watts of usable power, a slow, steady, unstoppable countdown that's been ticking since the day it left Earth. To put that decay rate into perspective, imagine a battery that started with roughly 470 watts back in 1977, enough to comfortably run several household light bulbs and a small appliance or two at the same time. Now imagine that same battery slowly draining, not because anything is broken, but simply because the radioactive plutonium powering it naturally weakens over time, the same way any radioactive material gradually loses its potency the longer it exists. There's no way to recharge it. There's no way to replace it. Once the plutonium's heat output drops below what the spacecraft's instruments need to function, those instruments simply stop working permanently, with absolutely no way for engineers back on Earth to fix it from this distance. Every watt saved by turning off one instrument becomes a watt available to keep another instrument alive just a little bit longer, which is exactly why these shutdown decisions get debated so carefully before anyone commits to them. For decades, that slow decline was manageable. Engineers simply turned off equipment the spacecraft no longer needed, like the cameras that had already photographed every planet it would ever fly past. But eventually, the easy cuts ran out. What remained were the actual scientific instruments, the tools that make this mission scientifically priceless in the first place, since nothing else humanity has ever built is out there collecting this kind of data. That golden record is worth pausing on for a moment because it adds an entirely different emotional layer to this whole story. Long before anyone worried about power levels or instrument shutdowns, engineers in the 1970s attached a physical record to both Voyager spacecraft containing greetings in dozens of languages. Recordings of nature and pieces of music meant to give any future finder a small glimpse of what life on Earth once looked and sounded like. Once Voyager 2 finally goes silent, that record doesn't go silent with it. It will simply keep traveling, a genuine physical time capsule launched by human beings, continuing to drift through the galaxy for what could realistically be millions of years into the future. Long after the spacecraft itself stops sending us anything at all, the record itself is a genuinely remarkable object once you look closely at what it actually contains. Engineers and scientists, led at the time by astronomer Carl Sagan, spent months carefully selecting what should represent all of humanity to whoever or whatever might eventually find it. They included spoken greetings recorded in dozens of different human languages, ranging from formal statements to a simple child's voice saying hello. They included natural sounds recorded here on Earth, things like wind, thunder, birdsong, and ocean waves, alongside recordings of human activities such as laughter, footsteps, and the sound of a heartbeat. They included a carefully chosen selection of music, spanning different cultures and different centuries, packed onto a single physical disc small enough to hold in one hand. Alongside the audio, the record includes over 100 images encoded directly into its grooves, showing everything from diagrams of basic mathematics and chemistry to photographs of human anatomy, family life, cities, farms, and landscapes from around the world. Instructions for how to actually play the record were even etched directly onto its cover in a kind of universal diagram using basic physics and chemistry that any sufficiently advanced civilization, wherever they might come from, should theoretically be able to decode without ever needing a translator or a manual written in any human language. Nobody who worked on that record ever expected it to be found quickly, or perhaps ever at all. It was built as a message in a bottle thrown into the largest ocean imaginable, sent out with essentially zero expectation of a reply, purely as a gesture, a quiet statement that humanity existed, thought carefully about how to represent itself, and wanted some small piece of that identity to survive far longer than any single human life, any single nation, or possibly even our species itself. So when people say Voyager 2 eventual silence confirms something we all feared, this is really what they mean once you strip away the exaggeration. It confirms that even humanity's greatest engineering achievements aren't permanent. It confirms that the physical laws governing radioactive decay don't bend for sentimental reasons, no matter how much we might want a 50-year-old machine to somehow keep running forever. And it confirms that right now, in this exact moment, we're living through the final working years of the only physical exploration humanity has ever conducted beyond the edge of our own solar system, with nothing currently built and ready to immediately take its place once it finally goes quiet. None of that means the story is finished yet, Voyager 2 is still out there right now, still transmitting, still collecting real data from a part of the universe we've never explored any other way. Every additional month it keeps running is a genuine bonus, squeezed out by careful engineering decisions made by a small, dedicated team who refuse to let this mission end a single day earlier than it absolutely has to. But the honest, unavoidable truth sitting underneath all of this is simple. The clock has been running since 1977. It cannot be reset. And at some point, whether that happens next year or sometime in the early 2030s, the very last signal will arrive. And after that, for the first time in almost 50 years, humanity will have no direct voice speaking to us from beyond the edge of our own solar. Says if this story genuinely moved you, that's exactly the point of telling it honestly instead of exaggerating it into something it isn't. The real Voyager 2 story doesn't need a fictional twist to feel enormous. A machine built before most of us were born, still drifting through interstellar space today, still fighting to send us one more signal before its power finally runs out, is already one of the most quietly incredible achievements in the entire history of human exploration. Consider just how strange this exact moment in time really is. Right now, while you're watching this, a message that took 19 hours to travel from Earth might be arriving at Voyager 2 at this exact second. A reply sent back might not reach mission control until sometime tomorrow. That kind of delay barely feels real in a world where video calls connect instantly across oceans. Yet somewhere out past the edge of our solar system's protective bubble, a 50-year old machine running on power weaker than a household light bulb is still faithfully doing its job, still pointing its antenna back toward a tiny blue dot it left behind nearly half a century ago, waiting patiently for whatever instruction comes next. Nobody currently knows the exact date this story finally ends. It might be next year. It might genuinely stretch into the early 2030s if the team's careful power planning holds up as well as they hope. What's certain is that the number of remaining working years is now small enough to count, rather than something comfortably distant enough to ignore. That shift from an abstract someday to an actual approaching countdown is exactly why this story feels different now than it did even just a few years ago, and exactly why so many people are suddenly paying close attention to a spacecraft most of them had honestly forgotten was even still out there. It also says something about the team of engineers still working this mission every single day, most of whom weren't even born when Voyager 2 first launched in 1977. They inherited a machine built by an earlier generation using computing technology that feels almost primitive by today's standards. They've spent years finding clever, creative ways to squeeze every remaining bit of science out of it before its power finally runs dry. That kind of quiet, dedicated persistence rarely makes headlines, but it's the entire reason Voyager 2 is still transmitting today instead of having gone silent years ago. Whatever the final signal ends up looking like, whenever it finally arrives, it will be the product of decades of careful decisions made by people determined not to let this remarkable machine go quiet a single day sooner than absolutely necessary. Think about the scale of what these engineers are actually managing here. They're not simply monitoring gauges and pressing buttons. They're making genuinely difficult choices about which pieces of irreplaceable scientific data to sacrifice and which to preserve, knowing that every decision is essentially permanent the moment it's made. There's no reversing a shutdown once the command has been sent and confirmed. There's no going back to collect the data that instrument would have gathered had it stayed on for another year. Each choice closes a door that will never open again, and the team making these calls does so fully aware of exactly what's being lost each time. And yet, despite the weight of that responsibility, the mission continues. Voyager 2 keeps transmitting. Its remaining instruments keep gathering information about a region of the universe that remains almost entirely unexplored by anything else humanity has ever built. The magnetic field measurements, the plasma wave readings, the particle detections, all of it continues flowing back across billions of kilometers, arriving on Earth 19 hours after it was sent carrying with it a small piece of a puzzle that scientists are still working to understand. What makes this moment worth pausing on isn't just the science, though the science alone would be remarkable enough on its own. It's the fact that we are, right now in these exact years, living through something that will never happen again in quite the same way. There will be other spacecraft. There will eventually be new missions built with better technology, faster engines, and more sophisticated instruments than anything available in the 1970s. But none of them will be Voyager 2. None of them will carry the specific golden record assembled by Carl Sagan's team, chosen with such deliberate care to represent humanity at that particular point in its history. None of them will have already spent nearly 50 years quietly proving that a machine built before most of its current operators were even born can still teach us something entirely new about universe, one signal at a time. Every engineer working on this mission today knows they're managing the closing chapter of something that began decades before they arrived. They inherited careful, painstaking decisions made by people who could never have known exactly how long their work would ultimately need to last, and they've spent years extending that legacy through their own quiet ingenuity. Somewhere out past the edge of the solar system right now, drifting through the emptiness of true interstellar space, running on a power supply with a hard and permanent expiration date, Voyager 2 is still listening for instructions from Earth and still calling back faithfully, patiently, exactly as it has for nearly 50 years, however many years it has left, whether that turns out to be 1 or 5 or stretches all the way into the early 2030s as engineers currently hope. That alone remains one of the most quietly extraordinary things humanity has ever built. A message in a bottle, cast into the largest ocean imaginable, still sending updates back home decades after anyone expected it to stop. A physical record of who we were and what we valued, destined to keep drifting through the galaxy long after the spacecraft itself falls silent, and long after everyone currently watching this video has become part of history themselves. That is the real story of Voyager 2, told honestly, without needing a single invented detail to make it feel significant. It already is. If this story genuinely moved you, if it made you stop and think about just how remarkable it is that a 50-year-old machine is still out there right now, still working, still teaching us something new, then subscribe and stay close, because whenever that final signal finally does arrive, it deserves to be remembered accurately for exactly how extraordinary it actually was. Share this video with someone who'd appreciate knowing that humanity's longest conversation with the edge of our solar system is still ongoing, one faint, patient radio signal at a time. I'll see you in the next one.